Now we're talking, 5, 6, 7, 8, 9, 10. We're going to blow that plume of smoke and fire, and we want to make sure all of our equipment is also safe, as well as the personnel involved. So we're looking for light winds. We've got it right now. It's fairly calm right here, sitting where we are, right behind the chamber. There was, winds of 2 or 3 miles an hour earlier, but we're keeping a very close eye on that as we march ahead toward test time.
Absolutely. We are excited to have you all with us tonight. Again, I'm Christina Gropp. This is our Senior Director for Product Design and Lead Research Meteorologist, Dr. Ian Jamanko. Between the two of us, we're going to walk you through tonight's test and bring you a little bit of IBHS Live inside wildfire science from right here at the IBHS Research Center in Richburg, South Carolina. Ian, it's been a really busy day here.
Yes, it has. We apologize for any of the audio hiccups that may have right off the top of our broadcast. We're keeping an eye on the levels. Got a lot of cables out. We had a wonderful visit this morning from Good Morning America, and we did a demonstration about the 0 to 5 foot home ignition zone this morning live on GMA. Rob Marciano was here. The folks did a fantastic job. It was a wonderful experience. But that was what we did this morning. So it's been a very active day.
Absolutely. We were out here doing wildfire work before the sun rose, and we're going to be out here after sunset tonight, bring you a little bit more with this structure right here. This is the structure we're going to be looking at this evening just over my shoulder. And Ian, let's tell you a little bit about the experiments that are going on tonight. This is one part of a multi-phase, multi-year, multi-organization project. Let's start breaking down this maze of activity that's happening in the wildfire space. It's a busy space.
Yeah, that's right. This is phase one of a large project with the National Institute for Standards and Technology, NIST. And this is just part one. So part two will actually bring in a full-scale house next to the structure you see behind us. So we've been working, earlier this year we did a few test burns to test out instrumentation. We are on burn, I think, number 5 in this whole test package that we're going to bring you live tonight. So it's a series that will go on. There's a few more burns to come as we look ahead over the next month. And then next year we'll bring in phase 2, where we actually have a big, large house that will go right up against this structure that we're working with right now.
So as good scientists, there's one variable that we change throughout each of these 5 burns that we've done, and that's either the material or the size of these different structures that we're burning. So tonight's is a very large wood shed, a shed that you'd often find in your backyard or my backyard, where you'd keep anything from lawn equipment to lumber for building a new deck. You name it, it could be in your shed. That's what we're going to look at tonight. What happens in a wildfire with your shed? Maybe it's a kid's play set. Maybe it's a doghouse, anything like that.
Yeah, the crucial part of this experiment is trying to understand how structures near other structures can essentially set them on fire. Now everybody, we're all going to sit here and, oh yeah, all the big flames, they hit my house. Of course it's going to, ignite. But
we need more detailed measurements.
That's right. We need to measure and understand what materials can withstand what type of heat energy or heat flux. So that's the amount of heat on a surface area. And also how much just heat itself can ignite materials, not just the direct flame contact. And you've probably seen lots of what we do here at IBHS. If you haven't, please check out disastersafety.org. You can see some of the wildfire ember testing that we've done right here. And that's just one of the kind of 3 major pieces of the ignition puzzle.
Absolutely. Some critical fundamental measurements that we're collecting right now is, again, Ian mentioned the beginning stages of this really big project called structure separation experiments. So this is, again, the shed that we're going to be focused on throughout the next hour or so as we bring you coverage. You can see some folks behind us getting set up. Now, we're doing all of this with the utmost safety in mind, and we are sitting here at a safe distance, but throughout the evening you're going to see folks coming in and out with different safety gear on.
Yeah, you're going to see a lot of folks, most of the crew that's going to be up close to the building, you're going to see them with respirators on. They're going to have their full fire protection suits, their Nomex suits on, and they'll come and go. You'll see them behind us. We'll check in with our product developer Armand Brody back there in a little bit, and Armand will take us through some of those safety checks with Sean McComber. And you'll get to see an insight how we stay safe in these kind of testing, how we collect the data that we do, and kind of the reasoning behind all of it, and how all this team kind of comes together to make an experiment like this go.
Absolutely. It takes a whole team, many of whom you don't often see on camera, but they're all making it happen, from the instrument techs helping make sure we collect that very, very important data to the folks who build the shed that we're about to burn down tonight, to collect those measurements, to the wildfire researchers, everyone. There's a huge team involved in all of this, and a huge shout out to all of them, because it's been a busy time.
It has been, and let's we're going to take a look back here in a minute of some of the past testing we've done this year on the wildfire subject, where we were looking at how fire spreads through essentially a bed of fuel, and what kind of gap you need to try to keep that fire from spreading. So that was some cool work we did earlier this year. And we want to show you guys just a look back at some of the highlights that came from our wildfire fuel breaks testing. So let's have a look. Welcome inside our large full-scale test chamber today. We get to bring you inside some of the science we're doing here, focusing on wildfire today.
Absolutely. So this facility is very unique. It's the only place like it in the world where we have the capability to reproduce Mother Nature's hazards in a controlled, repeatable manner. So that's part of what we're going to be looking at today, right? We're looking at how flames could cross a fuel break.
Yes. So basically, we have two fuel beds here. One of them is the source, the other one is the target, and we add the wind component again to this. And we want to look what should be the width of the gap that the fire doesn't bridge over. And this can be used in real world, as Dan mentioned in the video.
Give our viewers a sense of what we're looking for them to walk away with here today.
So what we're going to see in this first test is we're going to see a line fire started at the leading edge. We have about a 20-mile-per-hour wind, and that fire is going to spread through what we call our source fuel bed. It's about 40 feet long, 12 feet wide. We're going to see fire spread that 40 feet in under 10 seconds. I'd estimate maybe 8 to 9 seconds. And then it's going to reach a gap. And that gap currently is at just under 4 feet, about 3 feet 11 inches, or in metric terms, 120 centimeters. And what we expect to see in this first experiment is that fire to bridge. We're going to see the flames licking across the gap and to ignite the target source. And so in this 120 centimeter gap, we expect the fire to spread. In the second test, we're going to increase that gap size, and we're going to see what happens then.
Are we ready for the first test?
We're ready to go. I'm going to get started here.
I'm going to let you go, and I will backpedal here and get out of the way so you folks can see everything that's going to take place. We are starting the fire now, and off we go. As you heard Dan mention, moving across that source fuel bed. Dan said in around 10 seconds or so. Timing is everything when it comes to science. As you can see, that fire is quickly moving across that source fuel bed. Those pine straws are feeling it right now. And that fire is pretty much consuming that source fuel bed, those pine straws. And now we're looking at Wildfire Bridge. We're expecting it to. It is coming across that fuel break. And there you have it. We've got the flames on the other side from the source fuel bed to the target fuel bed. We got a thumbs up from Dan Gorham there. And the crew now will start to prepare for test number 2. Let me come back on camera here and just talk to you folks for just a moment. So there you see it. We got what we were hoping for with the first test. Got a couple of thumbs up from Dan Gorham. 3 feet 11 inches is the gap for the first test. 4 feet 3 inches is the gap for test number 2. We are ready for that second test. Dan is standing right by me. Dan, give us a quick preview.
Yeah, so the difference between test 1 and test 2, which we're about to start right here, is 10 centimeters, so just about 4 inches. And so that source, or pardon me, that target is just 4 centimeters further away, and we're going to see whether or not that 4 inches is enough that the fire doesn't spread the gap. We're ready to get started.
Let's go. Here we go. All right, I will get out of the way here. And here we go. Source fuel bed now being consumed by these flames. We will see if that bridge that you've heard Faraz and Dan mention, we will see if we get the bridge that we're looking for. Now coming up on the fuel break itself on the gravel. Now hopping across to that target fuel bed. So we see fire impact, not just on the source fuel bed. We also see it on the target fuel bed as well. There you have it. We were a bit uncertain what we would see with this second test. But yeah, the fire is licking up much of the fuel on that target fuel bed as those pine straws feel the weight of that fire and the 20-mile-per-hour wind speed.
An incredible day for us here at IBHS. We are proud to have brought you a live look inside our research as it happened. We hope you learned a little something and enjoyed seeing science at work in the everyday world.
Well, that was our first IBHS Live, Ian, back just a couple months ago, and here we are again.
Yeah, that was our very first time we've ever live broadcast a test in real time. It was a lot of fun to do. Really enjoyed that experience. There was another great test program looking at how fire spread through those fuels. That was in the big test chamber. You saw that was actually under our wind environment that we can create inside the test chamber. Now we're back here on the apron, and we're doing a little different kind of test.
Yeah, it shows the variety, even within the same peril, of all that happens here at IBHS within a year. Looks like we're about 15 minutes out from when we plan to start this test. It's a good time to check back in with our product developer, Armand Brody. He's standing by. I'm going to talk to you about a little bit about the safety aspects of what we're doing today and all of the safety protocols that are in place to keep the entire team here at IBHS safe while we collect this very important wildfire information. Armand, what do you have for us?
Thank you, Christina. Thank you, Ian. Well, our CEO, Roy Wright, always says, be safe, be smart, be kind. And it is with the utmost safety concern that we bring you this broadcast and this test this evening. Let me bring in our construction and facilities manager, Sean McComber. Hello, Sean. Sean is with us here. And Sean, we spoke on the fuel brakes test, and that was a great thrill for us to bring that to our audience, and I will do the same here. Walk us through what we have done as an organization to prepare from a safety perspective for this test and for this broadcast tonight.
Well, as you mentioned, safety is of utmost importance, and tonight we have the added hazard of fire. So we address that in a number of ways. First of all, we look at PPE. So we're wearing flame retardant clothing. When we have no wind like we'll have tonight, we also use respirators that are fitted with proper gas cartridges, as well as HEPA filters, so to filter out any particulate. We also have safety meetings beforehand, and everybody is properly trained. We'll have fire suppression on hand in the event that the fire does get out of control, but we don't expect that to happen. So we expect this fire to burn all the way down without any extra suppression. So
now, some of our team members are wearing particular clothing. I am not. Explain to our viewers why some folks are wearing some things and I am not wearing what other folks are wearing.
Well, we've identified a buffer. You're outside of the 100-foot buffer. You can see behind me, we're quite a distance away from the shed that'll be burning tonight. So anybody that's within that buffer will be wearing the special flame retardant clothing, PPE, including the gloves and respirators. So you're outside of that. So we've determined that that's a safe zone. I'll also be keeping an eye on everything, so that in the event that the fire does grow, we'll be evacuating this area. So you're determined you'll be safe.
Thank you. Thank you, Sean. And thank you for joining us. Thank you so much. That is Sean McComber giving us a preview, but more so just an overview of the significance of safety as we do this test. As I mentioned at the outset, safety, be smart, be kind. These are the philosophies by which we conduct our science here at IBHS. So I'll toss it back to Christina and Ian. A great evening of science ahead of us.
Thank you, Armand. We've got some remote cameras set up as well that will help us stay safe while bringing you a great look inside what's happening here at IBHS. We can do that thanks to some technology that really makes it easy.
Yeah, this is fantastic. I want to point out something that's going on behind us. You can see the guys moving the grid in front of us, essentially a system of cameras. We use machine vision to track the flames of this building. So we're not just setting a shed structure on fire. We have multiple cameras, we have multiple instruments. You're going to hear a little bit more about the instrumentation. We have a great package to share with you, and we'll check back in with Armand too to hear a little bit about that. But that's what the guys are doing. We're calibrating the camera system right now behind us. That's that black and white checkerboard looking grid. Those are known dimensions. And with that, that means we can actually use machine vision techniques and computer program to actually extract what the flame height, the angle of the flame is, using the cameras that are essentially encircling that shed structure back there.
That's right, Ian. It's so important to go back to the important data that's being collected here. Science is cool, and we love to bring you the cool science, but we also want to highlight the unique data that is being captured right along with the cool visuals that are happening. It's that data. That's why we do what we do, is that we can capture that data and our teams can go back, analyze it, and dive into what it means for wildfires and what it means that home and business owners can do to better prepare, because that's the end goal. That's the end goal here, is to bend down the risk curve, to reduce the impact of wildfires on our homes, our businesses, and our communities. And this is just one of many projects ongoing right now at IBHS working towards that goal.
Yeah, we 2017 and 2018 really put an exclamation point on wildfire and its threat to our communities in the West. And you know, a lot of this work, wildfire science, if you think about how we've looked at hurricanes related to how we build, wildfire is more in its infancy. We're just bringing science to tackle this problem. We're bringing more technology to tackle this problem. So science is catching up. Or if you think about hurricanes, we've been at this for several decades.
Right.
We know a lot of those science and engineering steps that can really help reduce the amount of damage. We saw it with our fortified program last year during Hurricane Sally, as well as Hurricane Ida this year. So it's been a great ride to start letting science catch up to this particular hazard and bringing some of the unique tools that technology now gives us to try to tackle this. And this is what this experiment is all about. It's being able to understand what is essentially the heat energy that's given off by this kind of structure. How close does another structure have to be before it gets ignited? How far away does it have to be? Is there do we need a certain distance of a gap? Is there some standard gap we can apply there? And this is really the foundational research that's going to inform all of that.
And how does the material that shed or that structure is made of, how does that play into what that distance is? There are a number of variables at play that we need to capture that data to understand exactly what we can tell homeowners.
Yeah. So that's a great kind of segue to take a look at kind of the uniqueness of this particular test program and some of the instrumentation behind it. There's miles of instrument wire back there. There's tens of sensors that are mounted on those rigs. You can see them sticking up with the aluminum foil on it. We'll hear a little bit more about that. But right now we want to take a look at Faraz Hedayati, one of our wildfire scientists, took an in-depth look at this project and some of the uniqueness about its instrumentation. So have a look.
So right now we are doing task 2 of phase 1 of structure separation experiments. So in the first task, we mapped the wind flow outside here. Now we are working on estimating how much energy is being released at the certain moment with time. We have different ways to measure the heat release rate or the energy release rate. One is the platform that you see over there. There are 19 beams, and on each side of the beam there are 2 load cells. So basically we're measuring the mass loss, how much mass of wood is being burned at a certain time. And then there is another optical measurement here to look at the heat release rate with cameras, and a lot of math is involved in that. The size of this platform, look at this, this is huge. So we can put, so the dimension is almost 30 feet by 40 feet. So we can put large sheds on this, ignite it, and then look at the mass loss rate. And also, again, looking at heat flux and temperature distribution around it when the fire is involved. So in addition of measuring the mass loss rate with the platform, those towers that you see around, those are heat flux sensors. So we collect the heat flux and temperature, and everything goes to the data acquisition system that is like in that shed over there. And the cable is like all the way on the ground. And we look at the data real time to make sure that we are measuring what we're measuring is the right thing. Otherwise, we have to alter the system. All we do here right now is the first special thing, in my opinion, is the scale of the test. This is full scale test. And also the data that we collect right now is useful for models. So up to now, there is no realistic heat release rate or energy release rate to be used in the models. But after these tests, this piece will be added to the models and make them a better predictor of the hazard.
Incredible work there from Faraz.
Yeah, it's always, I love listening to Faraz talk about the science we do. We're all science nerds here, but Faraz is leading this effort here at IBHS. He's our science lead on this particular experiment, along with our collaborators from the National Institute of Standards and Technology, that's NIST. So lots of big work that happens here at IBHS, and we're just proud to be able to bring you a little part of it here tonight.
Yeah, and as we go through the evening, we'll take you to talk with some of our scientists, talk about the data that they're collecting, how they're collecting it. There's so much instrumentation out there on the apron of the test chamber ready to collect data. We've got some friends here from the U.S. Forest Service with some extra instrumentation here to collect more data, so that it's just got a data frenzy after nights like tonight.
Yes, it is. So yes, our friends who work with us closely on the fuel breaks experiment from the Forest Service brought some specialty equipment down for this particular test. So we've got all sorts of monitoring equipment out there that are getting ready for this structure burn. So we've got a handful of minutes to go. Here in a moment, we'll check back in on the action out there closer to the test building with Armand Brody. So we'll be headed back out there. But yeah, lots of data numbers to crunch. And as scientists, we love this stuff. This is kind of what the fun part is, when we can go collect the data and be able to analyze it and see what it tells us and kind of solve the mysteries that are out there. So yeah, I'm going to geek out just for a little bit on the science nerd. I know Christina's a meteorologist too, so she's going to probably does the same thing from time to time. Us weather nerds seem to have that in common.
Oh yeah. Now let's start with some basic numbers, Ian. Let's not overwhelm our friends that are joining us tonight just yet. Some basic numbers. This shed is 12 feet by 24 feet. It's a pretty large backyard shed, and it weighs about 8,000 pounds. And we're going to put 15 wooden cribs inside. That's the material, the fuel that we are going to ignite inside it. Now, in your backyard, that could be anything. That could be the lumber for a project, a wheelbarrow, anything. It's just a representative fuel that we can keep fairly consistent across experiments.
That's right. We're gonna check in with Armand in a little second, give us some details on the cribs there. And these are simply just grids of wood. And we know essentially how much heat energy they give off when they're essentially consumed by fire. So they're kind of our standard unit of measure in the fire space here. So that's what we use to replicate like the fuels you would have in your shed, whether that's your tools like your rake, shovels, those kinds of things. And that's really what we're going to use to ignite this structure. So here in a moment, we will check in with Armand in just a second, and he'll give us some details here in a second about some of the instrumentation and some of the cribs that we're loading in there. So I'm going to get ready here to toss it back to Armand just in a second.
I think he is just about ready, Ian, to take that toss and get us some of that information. He's over by the shed right now. You might be able to see him just behind us. If we head over and talk to him. Armand, are you there?
Can you folks hear me? Wonderful.
Yeah, Armand, we've got a little bit of audio issues there. You might be a little far from the receiver. So we've got wires all over the place, wireless communications everywhere. We will check back in with Armand in just a second, and we'll see if he's ready to go. Armand, you got us?
I can hear you. Can you folks hear me over at the desk?
There we go. Now we got you. What do you got for us, Armand?
To my right. You do a little dance sometimes and look inside as close as we can get without getting onto the platform. Take a look inside. You see the cribs there, and this is where the magic is going to take place tonight. We tend to burn larger sheds here at IBHS, and tonight is going to be an example of that. You have the mass loss platform on which the shed currently stands. 15 cribs in the shed, and each crib is 3 by 3 by 3. We'll ignite one crib, and then the fire will spread to the others. And hoping that you can get at how this science takes place before the test takes place, which we are just a few moments away from that. A lot of moving pieces. Also, if we can, let's get a shot of the instrument rigs. There you see the aluminum foil Sometimes it's the simple things that help us put science together, and the instrument rigs are part of that. I'm hearing some radio chatter, so let me come back on camera here. I think we're just about ready for the test. I am going to come back on camera here. I'm going to toss briefly to Ian and Christina as we get ready for the first test, or as we get ready for the test is what I mean to say. Ian and Christina, let's take it back to you.
Thanks, Armand. A couple of audio issues there. Hopefully you caught most of what Armand was talking about. Get a little bit far away from our receivers, as Ian mentioned. We're out here on the apron. It's a new spot for us, so we're working out a couple of kinks, but trying to give you the best look inside our wildfire coverage over the next few minutes, when it looks like we'll be hoping to get the test started. I'm seeing the crew around start to put on more of their wildfire gear. You're seeing some of those respirators we talked about on, more of the wildfire resistant clothing, including a cover for hair to keep everyone protected. That is for everyone who is going to be on the concrete and closer to the structure where Ian and I are, has been deemed a safe area for us. And of course, we will continue to keep safety at the forefront of tonight's IBHS Live.
Yeah, as Sean mentioned, we're well outside the 100-foot buffer zone there, but you can see the crew there donning all their respirators and their protective equipment. Yeah, this is a new spot for us, so we are working out the kinks, but we're glad. I hope you got to hear a little bit of Armand's package there, and you can see up close inside those grids of wood. We call them cribs in the science world, but they're essentially just grids of wood that's meant to replicate the fuels that you would have in your shed right here. So there's a known load, and like I mentioned, they're kind of our unit of measure for fire in this scenario. So we're getting awful close. You can hear the radio traffic. We do have that piped into the audio, so you actually get to see a little bit of what's going on out there. And you can hear, we have some mics around, so you can hear some of the crew. And you can see we're just about ready to get going here. I think that's Lucas Faulkner. It's hard to see underneath all the protective gear. He's got the propane torch. As Armand mentioned, he will ignite one of the cribs, and then we'll actually watch the fire progression from inside and then eventually spread to the walls of the structure, and we'll see where it goes.
That's right, Ian. And we're watching right now as we get very close to the start of testing. The sun is starting to set, and that's what we want here. That darkness helps with that machine vision that we talked about just a little bit ago when you saw that grid. So,
time, 6:01 p.m.
All right, listen to a little bit of the radio traffic there. It seems like we're getting pretty close to the start of testing.
Yeah, I think we have ignited the first crib. We can see it in one of the camera angles. I think that's Brenna Meisenzahl with one of the shoulder mount cameras there. You can see inside the crib right there, inside the shed, I'm sorry. You can see our initial fire start to build on that first crib that was ignited. And here we go.
We are underway now, right at 6 o'clock. We have the first ignition inside the shed. Now, we ignited this ourselves in this scenario, but this is representative of when a wildfire, maybe it's throwing embers on your shed, and that's what starts the ignition. But now the data that we're collecting is what happens once you have ignition. We're starting our look at ignition and going, what happens after that? How does that make the surrounding areas vulnerable because of a structure like this shed burning?
Yeah, and this particular shed is a full wood assembly. And what you'll see is the cribs inside will start to catch, and you'll see fire spread up into the roof system. You might see it actually poke out. There are windows on this particular shed too. Those are vinyl. They'll likely melt away relatively quickly once the heat starts to build up inside the structure. Some of the interesting observations we've seen from some of the other sheds, we looked at metal, and the metal sheds are actually quite good at containing a lot of that heat energy. While the metal itself deforms, it does a pretty good job at keeping some of that radiant heat energy contained, and the flames themselves a little bit, and could be something we may look at as a mitigation option down the road as this kind of work and this kind of science marches on.
Ian, you're throwing out a couple of terms here that are really important in wildfire, and a couple of those: radiant heat, flames, and then the third one that's always in that mix is embers.
Yeah, those are the three mechanisms in which you can essentially ignite a structure in a wildfire scenario. Now, we know a lot of some of the biggest threats we face is from embers, but once fire spreads into our neighborhoods and our communities, that's when we start to have all three mechanisms basically working all at the same time. And you can see, think about for those who are familiar with the Tubbs fire, That's exactly what happened within the community of Santa Rosa. We had fire spread into a densely packed suburban area, and now we put all three of those mechanisms at play and ended up with a catastrophic outcome.
You're seeing that fire that started down in that first crib as it's grown in the vertical up towards the roof structure. So we got a couple camera views that we're going to be switching around to show you as this fire progresses. But Armand, I believe, is standing by with a few more comments he wants to add as we'll keep looking at this shed structure. But Armand will come in, bring his audio in so that he can chime in and add some observations that he's seeing from over where our wildfire team is standing.
If you guys can hear me, I just wanted to add that speaking with some of our fire folks, in particular, Dan Jimenez from the U.S. Forest Service, and 2017 was a key year when it comes to wildfire research. It's as if 2017 was a sort of a shot in the arm to help us push forward in our wildfire research efforts, and IBHS has really captained the ship, if you will, when it comes to helping people understand the significance of wildfire research as we see the effects of climate change and all the things that are adding up now and coming into play, and really making the significance of wildfire research scream louder than it ever has before.
That's a great point, Armand, and we're starting to see some of the smoke come up through the roof, it looks like, Ian, of this shed. That fire is getting going in a hurry. It's only been ignited for about 3-4 minutes now, and we're already seeing smoke kind of billowing up.
Yeah, you can see the smoke now billowing out of the roof system and out the front door, and you can have fire spreading along the ceiling inside the shed structure there. That large instrument right there with the aluminum foil on it, that's one of the specialty gauges from the U.S. Forest Service. Armand mentioned Dan Jimenez. Dan joined us. He was part of our fuel breaks work several months ago. Dan is part of the team that deployed that instrumentation for this test. So good to hear Armand and Dan over there, and we're glad to have those folks. You can see more and more smoke. The fire itself inside the structure is becoming more intense. It hasn't spread to the external walls yet at this point, but you can tell we have a large fire, as we would have expected, ongoing now inside the shed.
We do, and Ian, what's always amazing to me is just how quickly this happens. It's only been about 5 minutes since ignition, and this fire is quickly taking over this shed. And when you think about how this plays out in scenarios out in the real world, in people's yards, if a firefighter's not there right away, you can quickly see how the entire shed can be overwhelmed. And what that means for the surrounding structures, well, that's what we're looking to figure out with experiments like this controlled shed burn tonight.
And one of the vital components is, one, having your home be defensible for the fire service and firemen. And sometimes it's just luck in a wildfire scenario that they just happen to be by. So we're trying to find what are the ammunition for a home to be able to fight back and essentially have some elements to help protect. You can see a lot of black smoke now billowing from the shed. That's some of the other materials that the structure's made of. So that's some of the vinyl materials that are inside, probably some of the paint coating as well that's inside this shed. So you see a lot of black smoke now billowing from the structure as that fire inside gets hotter and hotter.
You can also see our camera crews have started to back away from the shed, and we will continue to do that as the fire grows. We are again keeping safety at the forefront of tonight's broadcast, but we want to give you that look. We've got some other remote cameras that will continue to bring you throughout the broadcast, and it won't be long before you really see the shed burning. We won't have to be very close for you to see that fire. But Ian, let's talk about some of the instrumentation that we can see in the shot as well. That instrument rig wrapped in aluminum foil, which I just think is so cool. It's such a basic kitchen thing that we all have and we have all used forever. And yet it's used in almost every wildfire project as well. Let's talk about some of the things that instrument rig is collecting. It's collecting a heat flux.
Yeah, so there's multiple levels of instrumentation, and Christina mentioned heat flux is one of them, and we're going to throw out some science terms, so we're going to learn a little bit tonight. So heat flux, we're simply looking at the amount of heat energy that it's imparted on a surface area, and that's what that's measuring. So as we look to see what are the heat flux amounts that cause ignitions of materials, this is a vital variable to collect. We have quite a bit of flames now poking themselves out the front door and along the roof of the shed now. So that's what those sensors are measuring. And of course, yeah, that's classic store-bought aluminum foil little MacGyvering. Our sensors themselves are rugged to be able to take this kind of heat, but the instrument wiring, you can hear some of the radio traffic behind me of what's going on. And our sensors can take it, but yeah, we want to protect the wiring as best we can. And actually, some of those sensors have a water cooling system. We actually circulate water around in the jacket to make sure the instrument itself is rugged enough to withstand some pretty stout amount of heat that comes off of the structures when we do these kind of controlled burns.
You can see that those flames coming out the front door, and you can see a lot of smoke coming out right along where the eave of that roof would be, as that fire is really going now inside that shed. This camera view really shows how those flames are coming out of that front door and all of the smoke coming out. Now we've got it coming out the gable end of the shed as well. This is all transpired now in just about the first 10 minutes of this burn.
Yeah, that's right, Christina. You know, it is remarkable how fast this happened. You saw a little bit of how fast fire spread through our fuel bed, our pine straw fuel bed in the package earlier. Fire happens really, really fast, and whether it's a house fire in a normal, I hesitate to say conventional setup, but that's, you know, a lot of times what we think of in fire, or a wildfire scenario where, say, just some landscaping got ignited near your home, and now 10 minutes later your entire wall or front of your home is engulfed in flames, or in this case, this is the shed structure. So you see how rapidly this actually takes place, going from essentially nothing to a really bad situation unfolding. You
saw our team standing in front of those doors just before we lit this structure and ignited it. So you know how large this is, and these flames are now jumping well above the roof line of the structure. There are flames well above that roof line, and that's part of the risk and part of why that machine vision grid that you saw us calibrating before we ignited the first crib, why that is so important.
Yeah, so, you know, we're going to be able to measure and track how those flames propagate and the height. You know, my guess sitting here, I'm going to guess we're somewhere close to 20 plus feet or so tops of the large flames coming out the shed door. But we can actually get precision measurements by using all those remote cameras that are essentially around the building. We're showing you some of ours that we have hooked up to be able to kind of span the area around the structure, but we have additional cameras that are going to be used in this vein to track that kind of flame and essentially where it goes and what it does.
A great point there, Ian. We can make some guesses now, but afterwards, that's when the real data analysis will begin to look at just how big those flames are. It looks like we've got flames now coming out the backside of the structure that is away from where those front doors are. So flames now coming out both sides of the structure. We want to bring back in Armand Brody while we keep watching the flames and how this shed is burning. We'll bring him back in, at least on audio, to join the conversation. Armand, what do you have for us?
Yeah, wow, what a sight this is. And as you folks have mentioned, it does not take long for fire of this impact and magnitude to just consume a structure. But you folks have a little more time here at IBHS, and in Ian's case, a lot more time here at IBHS than I do. I'm curious from your perspective, what does this say about the emphasis that we as an organization have placed, of course, in partnership with CAL FIRE and the Forest Service and NIST and all of our great friends who help us in these endeavors? What does a night like this say about the kind of commitment that we've made to wildfire research as things really begin to pick up now?
Yeah, we've got a large, we almost start to feel a little bit of the heat now on the back of our neck sitting over here. You can see a large fire. But yeah, Armand, it's a really good point. I've been around IBHS now for 11 plus years. And early on when this facility was built in 2010, we knew wildfire was going to be one of our core perils. We study essentially windstorms. We look at hail, wildfire. That's kind of our bread and butter here at IBHS. And over the time, we've looked at essentially all three ignition mechanisms that Christina and I have talked about tonight. And you've seen just the work we do grow. We've always been looking for collaborative partners. We work with the Forest Service, Cal Fire. We talked about NIST already, other entities, the academic community. It's just been a great 10 plus years to see where science can go and how technology in a facility like this, but also when you bring in your partners. We can't do it alone, and neither can our partners, and that's how we make science go really, really fast. And that's how we can advance our understanding to better protect homes and businesses. And that's essentially what we're here for. That's what IBHS is about, trying to stop that damage, displacement, disruption that we see that unfortunately keeps happening. And these kinds of bad events, whether it's a tornado, a hurricane, a wildfire, even a big kind of hail event in, say, Dallas. I mean, just all of it keep happening. They're not going away, and in some instances getting worse. And it is really key that we take these steps now to start to figure out what to do to protect our homes and businesses.
Absolutely, Ian. And as we've been talking here, it looks like the roof has collapsed on this structure. We're starting to see some pieces of it fall away. As you just saw another piece fall off, it looked like that was maybe the window, those vinyl shutters really drooping down as they've melted. We can feel just a little bit of the heat from where we are, but that's that important information that those sensors around the structure are collecting. How much heat energy is being given up. You can feel a little bit of it, but those sensors are measuring that really important, fine, detailed data that we need to know when you're talking about where does ignition occur for something that's around the structure.
Yeah, so that's exactly what's going on. All that data comes into a hub that's roughly about 50 feet in another building behind our test building. We're sampling many data points per second, so we can actually see what's going on. And another piece of unique instrumentation we haven't talked about, this whole thing is sitting on a giant scale.
That's right. It's like a giant kitchen scale. You heard Faraz mention it in his piece right before we ignited the structure. We're calling it the mass loss platform, but it measures the mass that's on it just like a giant scale would.
So you and I might think of this as the scale, say a 18-wheeler big rig drives on at a weigh station, something like that. But this has a grid of load cells. That
we build.
That's right. We built this, fabbed it up here at IBHS. And it's got multiple load cells. These are little instruments that are in your kitchen scales or your bathroom scales or even in those really big ones. And it's meant to be a precision measurement device. We can actually watch our team walk on this platform. We can weigh ourselves if we really wanted to. And it has a high degree of not only accuracy, but also precision. And we're looking at the amount of fuel and the mass that's essentially being consumed by the fire and the rate. How fast does that happen? And that's another key to understanding really the intensity of the fire, how close a structure could be to this particular shed if it ignited and survived, or on the flip side, if it's too close, how close can it be when that ignition happens and that particular shed becomes essentially an adversary of your home.
That's right, Ian. How fast we're losing mass, it connects to the energy of the fire and of what the structure that's burning is giving off. And that's why it is such vital information for us to collect. Now, when you're talking about a structure of this size, a bit of a challenge to collect, but not a challenge that we're not up to face. We face some big ones here, and we're willing to build the instrumentation to get the data we need.
That's right. Full scale is a big challenge. We do a lot of our experiments full scale, meaning these are the exact structures. And we actually have a test home in our big chamber right now. I'm looking right at it just across the way. And it's so vital to connect small experiments to field observations, to full-scale experiments, back to the field, back to the small end. It's essentially this wheel that spins. And that's, to be honest, as a science nerd, I love that aspect.
And it all
science.
works together. You can't take out one piece of that wheel. We need all the pieces to help put the parts together the right way, in the right order, to really make science make a difference. Science is cool, and science can transform our lives for the better.
Yeah, speaking of technology, you see our drone flying, shooting in front of the fire, collecting video imagery. And you see now our structure, we've lost the full roof system. It's actually collapsed inward now. and we're burning not only the fuel, the cribs that are still inside, but the structure itself. So you can see the framing, the 2x4 framing, burning, obviously extremely hot at this point. We've consumed a lot of the wall siding. That was wood, wood paneling. That's mostly consumed except for that near wall that you could see in one of the previous views we had. But now you just expose the entire framing now, and the cribs inside continue to burn.
Those cribs now each weigh about 250 to 300 pounds. That's what you can still see, those grids sitting inside what's left of the shed structure. Those are burning away as well, and this fire will continue for quite a while as we watch how this plays out. Now, as Ian described, wood cribs and wood sidings, you may be thinking, wait, wood burns? Of course. It's not just that it burns, it's how does it burn? At what temperature? How much heat's released? These are all of the really critical pieces that we need to understand. Not just that it can ignite and then burn, but how does it burn? That plays into the vulnerability of everything around a structure like this, whether again that's your shed, a kid's play set, a dog house, whatever the small structure in your yard may be. How does that make your home more or less vulnerable?
And when we look at these kind of auxiliary structures, you absolutely, if you live in a wildfire prone area, you want to get these, do not have them up against your house, especially anywhere inside 5 feet. Preferably, if you can, you want to get it 30 feet or beyond. Now, some of the work we're doing is trying to figure out what is that actual distance we can recommend. But sometimes think about my neighborhood. My 30 feet away is just not possible. And so we want to understand, say you have concrete fiberboard siding on your wall, but you have a wooden shed. Can that concrete fiberboard siding? We know we build stick-built homes. We got wood framing, wood sheeting. With
if
some
you
kind
watched
of
GMA
cover.
this morning, you saw how important fiber cement board siding can be.
Yeah, and at some point though, you will build up enough heat energy or flame contact that you can ignite the wall sheathing, the wood actually behind that. You can start to melt the paint, those kinds of things. So we want to understand when does that happen? What are the conditions under which that can happen? And can we prevent it simply by moving these structures away? Or on the flip side, can we actually treat these like the same home ignition zone or defensible space concept where we gotta make sure that fire never gets to those structures by putting in the same protections that we do on our home, like that 0 to 5 foot home ignition zone, trying to keep combustibles out of that area. That's one of the most crucial places to look. And the key is to understand, do we have to do that for sheds like this?
Right, how do we make this structure that you saw earlier that is now crumbling away just over my left shoulder, how do we make that safe to be on your property during a wildfire scenario? We do have Armand again. He is standing by with Dr. Faraz Hedayati, one of our wildfire research engineers. They're going to give us a couple of comments on what is happening right now as we continue to watch this burn play out behind us. Armand, what you got for us?
Armand is here. Faraz is right here with me. I know you got a lot going on. I'll try to keep it brief, Faraz. But just walk us through the process of how we prepared for this and what we're looking at right now.
So what we're looking at right now is about 40% of the initial mass is burned. So we monitor the mass loss like real time, and we can correlate that to the energy that is being released. So again, 60% of the mass is there, 40% is gone, and heat flux around the shed is about 5 to 15. And to put that into a scale, you cannot tolerate more than 1 kilowatt, otherwise you get sunburn. So this is a pretty hot fire.
What impact did the weather play in preparing for tonight?
Yeah, we were almost at the edge of like not testing today because of the wind, but well, it turned out to be good. We will not test more than if the weather is like more than 2 or 3 miles an hour wind. So we were around 6 miles an hour before the test. Now it's below 1, so we're good.
And where are we going next with this research?
So the next step is to burn these sheds with wind and then see how much the flame stretches and basically what's the role of wind in fire spread in communities.
I know you've got a lot of places to go right now. Thank you so much.
Thank you.
All right, Ian and Christina, I will toss it back to you.
Thanks, Armand. Some great insight there from Faraz. It's great to hear from our wildfire researchers as the research is happening. You can hear what's going through their mind, what they're watching. Faraz was talking about the data that they're already seeing from the mass loss platform that is letting them know how much of that mass we have, just as its name would suggest, how much of that mass we have lost as this burn has been underway for just about 23, 24 minutes is right where we're at now. And you can see just over my shoulder what is left of that shed that is burning. Just a few of those exterior framing members, it looks like. Those wooden crims inside the fuel that we initially ignited, those you can still see pretty well.
Yeah, you can. The cribs, this will burn for a while. And those cribs, the amount of essentially fuel that's there is fairly significant. So this will continue to burn. But you can see the structure itself has essentially collapsed on itself now. There goes one of the final kind of wall sections. I'm going to look back over my shoulder. You can see the stacks of cribs in there, looking at kind of an extreme fual case.
There goes another wall.
Ship. Yeah, there is a little bit of framing left as we kind of hop around the cameras around the structure itself. But this will continue to burn. We'll stick with it for you know, we were going to continue on to 6:30, but if you guys out there in social media land want us to stay with our coverage, please send us a Facebook note, just say hi. We are keeping an eye on our social streams as well, so please do that if you want to see a little bit more of the burn continue. But this will burn for a while, and this actually, the shot we have up right now is a really good one. You can see the multiple Forest Service pieces of instrumentation. Those are the two kind of short rigs with the big kind of larger pieces of aluminum foil covering the instrument pack there, as well as our tower on this particular side. And you can see the lowest level of instrumentation, that little arm, it kind of looks like a hand sticking out. That houses those heat flux sensors as well as a temperature sensor, measuring all of that information as it comes in to our data acquisition system.
All of that instrumentation is in addition to some of the cameras that we have around the wildfire team, Dan and Faraz. They also have some IR imagery looking at the flames as well. The amount of data collected during the past 25 minutes since we ignited the structure is just tremendous, and that will fuel research projects and analyses for quite some time as we're just watching kind of in awe as this structure continues to burn just over our shoulder. It's impressive what we've seen over the past 26 minutes, Ian.
Yeah, again, you know, 26 minutes we started with a fire inside the shed, and now we've got a complete loss of this particular structure. Again, the phase 2 of this is to put a full-size house, and we'll actually slide this toward us into the wind field, and we will start to look at how the flame from these kinds of burns impinges on a home. And that's the next piece of this puzzle. We're going to collect all this foundational data right now. We will come back. We'll know everything about these sheds. We'll know a lot of the how much heat energy it gives off, what are the maximum temperatures it can produce at what distances away from it. And then next year, we're going to come back and we'll have the home nearby and really take this project into phase 2 and start to look at the home ignition scenario. So if Armand could hear me, and I think Brenna over there, if we want to go take a look at the IR camera, you guys can mosey your way back, and we can show you a little bit about what's going on of how we use infrared camera work to look at this particular burn. We use a very sophisticated infrared camera for all of these experiments. We have it going right now as well. I see in our feed, we can see Armand and Brenna headed back over there. So we'll check in with them in a little bit. As you can see, just a couple of those wall studs still remaining on the structure. The cribs continue to burn. They will continue to burn for some time. And it's again, wildfire and just the fire scenario, so impressive about how fast this goes.
It really does. It never ceases to amaze me, Ian, just how fast all of this plays out. And when you think about how that translates into the real world of how fast a firefighter would need to be on site in order to extinguish that ignition. We often talk about it with wildfire. You often see the damage modes as binary. Either a house was not impacted or it's a complete loss. And we want to start finding some gradients in there. How can we keep homes from being a complete loss?
Yeah, unfortunately, that is the case with wildfire. We often see it's either a yes or no answer. And one of the steps too is, can we transition this into at least get to some damage as opposed to a total loss like we see with the other hazards, and eventually get to the fire resistance element and start to bend down the amount of structure losses that we see from fire.
That's right, and it looks like as we talk about working towards that goal, Armand standing by with Daniel Gorham now to look at that IR camera that we were referencing earlier. Armand, if you're ready, let's talk to Dan Gorham now.
Armand is here, and so is Dan. We've got so much going on, and hopefully you've been able to be with us and document everything as Ian and Christina have walked you through this amazing experiment, the structure separation experiments that we've done here tonight. All right, Dan is here with me. Dan, there's a computer here. I'm looking at it, but tell me, I'm going to slide over here, and I'm going to let Brenna come in here as you talk and just explain to us what you're looking at here.
Okay, sure. So this is the viewpoint of our Telapse multispectral IR camera, infrared. And so this is actually one of the filter wheels. This is essentially focused in on, you saw these rigs right here. This is where we have heat flux gauge. You can see that as a signature here. And the color spectrum is giving you different radiative or infrared wavelengths. And so we use this camera, it's actually tilted on its side. We want to visualize the plume. So from my finger, from left to right, that heat was going up. At this point, most of the shed has fallen down, so we're just seeing the burning cribs. But what we're using this camera to do is to actually visualize the plume coming up. One of the things that we're looking at in this research is, the flame height and the plume height. And with the IR camera, we're able to, with just our naked eye, see the smoke. With the IR camera and the multispectral, we can see different particles like CO and CO2. And by visualizing that, we can have better estimates of both the flame shape, the flame geometry, and the plume height.
Truly every aspect of our research being covered here for this amazing structure separation experiments burn that it's been quite a privilege and an honor to be a part of. Thank you so much, Dan.
My pleasure.
Christina and Ian, I'm going to toss it back to you.
Thank you, Armand, and thank you to Daniel Gorham, one of our wildfire research engineers out here tonight, for taking a moment to step away from the action to walk us through what we're looking at. Ian, as meteorologists, we're used to looking more at IR satellite imagery, but in this case, it's an IR camera looking at flames. It all is so important to help us see what we can't see with the naked eye.
Yeah, as you saw, Dan walk us through it, you get to track the flames and the structure of them, which is really, really neat. We had a good question come in. I'm going to let Christina handle. We're trying to get Armand back here in a second to grab Dan or Faraz to potentially answer our question here that came in from one of our viewers. So thank you for submitting that.
Yeah, one of the questions that we've had is how did we determine the load to put inside the shed? And while we may track down one of our wildfire guys to help us answer that question, let's talk again a little bit about how we've varied this. We've put a different amount of fuel, those wooden cribs or wooden stacks, wooden grids, inside the different sized sheds.
Yeah, so like all science experiments, we have a set number of variables. We want to control most of them and turn the knobs on one or two.
That's right.
And so for a lot of these burns, as we walk through them, we'll use different amounts of fuel that go in the shed. And some of it is going with fuel with essentially the type of shed, the size of shed. So we increase the amount of fuel for the larger shed. As you would expect, more things are actually put in it. I certainly do that with my stuff, but it's also, we march through the set of variables over time, basically turning one or two knobs at a time to be able to actually really look at kind of the relationships, the curves, how much fuel equals what heat flux, what's the rate of mass loss that goes with this, what's the type of shed, how fast did it collapse, how fast did its mass go away through all of this. So wonderful experimental testing, because meteorologists, unfortunately, this is one of we don't get to turn the knobs on the real weather, but we get about to come as close as we possibly can here at this facility. And this is just kind of an example of that, where you got a whole bunch of variables, you want to keep a bunch constant and turn the knobs on one or two to see what the actual relationships are.
That's right, and I think Armand is standing by again with Daniel Gorham to provide a little bit more insight and color from our wildfire team as to how we make all of those determinations. Armand, are you there?
Armand is here, and Dan has been able to rejoin me. You got a lot going on, sir.
Yeah.
So we certainly do understand. Christina and Ian, did you folks have a question from our chat? I wanted to make sure I didn't miss that question that we might be able to ask Dan while we have him here.
Sure. Why don't you relay to Dan, Armand? The question was about how we determine how many wood cribs to put inside the shed.
How do we determine the number of cribs to put inside the shed is the question.
Yeah, good question. So for this test, we started with 15 type 6A cribs. Each one of those cribs is about 3 feet by 3 feet by 3 feet, and they weigh about 300 pounds. So it's a really good question about how many to put inside of it, and it's a complicated answer. I would use the term fuel load to describe it. We're using these wood cribs as surrogate for fuel load that you might find inside your shed. You know, there's lots of surveys to study the fuel load in office buildings or amphitheaters. We don't have a good fuel load survey for sheds. And so really the basis for the number of cribs for each size shed, again, for the very large here, 15, for the smaller sizes, fewer of them, was our best guesstimate engineering analysis to say, what do we think the amount of fuel inside of it? Yeah.
So let me ask you also about how the cribs were arranged in the shed. What's the significance of that?
Sure, yeah. So, you know, again, so you say you have 15 cribs. How do I fit them in here? First is the geometry. How do you get them in? And our production team was really clever in being able to get them inside there. So first, getting them in was no trivial fact. But then how do we lay them out inside? This large of a shed, we think it's typically used as a workshop. And so in your shed at home, you might have stuff along the walls so you can move from your tool set to your wood pile to what have you. And that's essentially the layout that we used. A C shape, you could get in the door, and then the fuel load was primarily around the perimeter.
Thank you, sir.
Yeah.
All right, Ian and Christina, I don't know if we have any more questions for Dan.
That's
if
it
not,
for
I will
right
let him
now,
step away
I
for a
think.
moment.
Yeah, that's it.
All right,
right
sounds
now,
good.
though.
Thank you, sir.
On
I'll toss
questions
back
at
to you
least.
folks.
But if you have any more questions, feel free to pop them in the chat, and we'll be happy to take them and track down our wildfire researchers as they have a minute as the shed continues to burn over our shoulder tonight. We'll pull them away as we can to answer any questions that you have.
Yeah, that was a great one. So keep them coming. We'll stick with you guys a little while longer. Our coverage originally slated to end right around 6:30 Eastern time, but we'll stick with this. You can see the shed now really starting to burn down. I hesitate to use the word shed now. We're left with kind of the remnant fuel that was inside of it. The structure is nearly completely gone. And so, yeah, we'll stay with this just a little while longer so our coverage rolls on. But if anybody out there watching has any more questions, throw them. We'll try to get to you and bring back some of our fire experts. But
yeah, you're seeing some other action happening behind us as we make sure we keep everything safe. The fire ongoing on that platform, but you've seen some of the team around making sure that all the instrumentation, all of the wiring that we need to make sure that we collect that very important data. They're making sure all of it is protected as we move through the evening.
yeah, so you saw the guys spreading some sand out there. The instrument wire actually is fed through wireway that goes back to the shelter where the data acquisition system is. So we're making sure that any small, maybe ember-driven fires that snuck beneath the platform that maybe began to smolder, we make sure we take care of those. We don't want that wireway and that wire inside of it to have to deal with a fire and potentially melt and damage the wire, and we'll have to rewire it for the next test. So that's what you saw the guys doing, spreading a little bit of sand out there to put down maybe a couple of embers that had fallen right along the edge of the mass loss platform, are really very, very sophisticated scale that is doing its thing.
It is, and Ian, those data points are obviously the most important part of tonight so that we can collect that data. While we love bringing you the visuals and bringing you inside the wildfire research that happens here at IBHS every single day, it's that data that we have to capture so that we can transform what is a cool evening of science to watch and nerd out on. Watch that turn into some actionable information for home business owners, policyholders, the insurance industry, all of our many audiences.
Yeah, absolutely, Christina. And we want to really point folks, if you're wondering how all this information makes it into the things that you and I and all of us as homeowners can do to protect our home against wildfire, especially for those who may live in the West or maybe have some experience with wildfire. We developed, along with some of our partners, a virtual reality experience for your cell phone. It's called Wildfire Ready Virtual. Please go to the App Store, whether it's Apple or Android. It's available for both. Takes you through a very, very short survey. You can see going on the screen right now to help understand what are some of those vulnerable spots. But we've got this really cool immersive mixed reality piece where you can project a home and actually walk around it and see some of those vulnerable things and some of those actions you can take with just some sweat equity to really start to bend down the risk that your home may face from wildfire. So please go check that out. It's available for both Apple and Android. It's out there. It's free, completely free, and it's a pretty cool science application to show you where this work goes and how it gets turned into guidance.
From cool visuals right here with us live to cool apps that you can use every day around your home. But Ian, another really cool piece of this app, we just updated it with a brand new section.
Yeah, it came out first last year, and we updated it to conclude a little bit about the work we're doing right here. Understanding the vulnerable spots around your neighborhood and your community, and have that conversation with your neighbor. Talk about the things you can do together to help make your home more wildfire ready. So please check that out. Wildfire Ready Virtual, really neat mobile device. It will be soon available too for those fancy Oculus users who want to put the goggle set on. But that's coming soon, but right now available for Apple and Android. Please check it out, free of charge. It's a really neat way to look at some of the science in an immersive platform using some of the devices that we have in our pockets every single day.
And that you're probably watching our live stream this evening on as well. Now, Ian, this fire behind us now, what's left of the shed, it doesn't look nearly as impressive, yet it's still important data that we're collecting, and we're not going to put this fire out.
No, we will let this go, and we will measure the total amount of mass that comes off of this. So we'll let it burn out. Our crews stay late. We do a lot of shift work during this particular project to make sure, one, we're monitoring for safety's sake, but also the data stream that continues for this particular experiment. So really, this was a great evening of science, and we apologize for some of our audio hiccups along the way, still testing out some of this new technology here. But we hope we brought you inside the work we do here at IBHS. And as a whole, what the property insurance industry has committed to the resilience movement and this facility here. We opened in 2010. We've been around now over a decade doing this kind of work, really with the goal to stop this cycle of damage that unfortunately we see far too often.
Absolutely, Ian, a great point on why we do this every day. We're excited to bring you these events periodically on social media, but this is the science that happens every day here at IBHS with a really passionate group of carpenters and technicians and engineers and scientists. Everyone at IBHS is passionate about the mission that we are dedicated to and really finding the solutions to reduce the impact of these weather and climate disasters on our lives.
Yeah, that's one of my favorite parts about working here at IBHS. Not only that every day is different, and we got this today, we had GMA this morning, we got to bring you a live experiment tonight. But again, I don't think you'll find a more passionate group of people that really, we just want to help. That's all we're trying to do here. So I want to give a couple of really big shout outs and thank yous. Aubrey Marcinko, our technical director for tonight's broadcast, back in the control room, assisted by Amanda West helping with the audio side. Of course, Christina with me. We had Armand, Brenda Meisenzahl working the cameras there with Armand out there, Dan Gorham, Faraz Hedayati. I'm going to rattle them off. Sean McCover from the production team. I saw Rick Baker back there.
Don't forget our photographer extraordinaire, Lauren Wilson.
Yep, Lauren Wilson. You saw the drone hovering around. That was Lauren's work, handling a lot of the science and video imagery for this particular test. So great stuff. And there's many more back there. Joanne Battle, I think I saw him roaming around. And many more that I can't think of at this point. We can rattle them off all day, but a big thank you to our whole team here at IBHS and letting us take you inside our wildfire science.
Have a great night. Thanks so much for joining us.